Hello, this is Maria from Math Mammoth, and this is Mathy, my mascot. In this lesson, we are looking at zero and negative exponents. What are those? Let's look at these tables and some patterns here. We have looked at just normal positive exponents. 2 to the third power would be 2 times 2 times 2, right? Repeated multiplication. And then 2 squared is repeated multiplication, 2 times 2. And then 2 to the first power is just 2. But then what? Because you can't think of repeated multiplication when there's a zero exponent or a negative exponent. But we can think logically that if we follow this same pattern, you see, from 8 to 4 is a division by 2. From 4 to 2 also is a division by 2. But just taking half of the number going this way. So what's 2 divided by 2? Just 1. And what's 1 divided by 2? For this one we would get half. And then half divided by 2, or just half of it, half of half, is 1/4, and half of 1/4 is 1/8. That could work for zero and negative exponents, that kind of thing. Let's do it again though, with this number here, 4 as our base. 4 to the third power is 4 times 4 times 4, 64. And then 4 squared is 4 times 4, and then 4. And now, in each step, we have a division by 4. So 4 divided by 4 is 1 again. So 2 to the 0th power, 1. And 4 to the 0th power, 1 again. 1 divided by 4, well, that's easy, 1/4. And then that divided by 4. Okay, in fraction division, you need to use the reciprocal. And so you actually multiply it by 1/4, you get 1/16. And here you get 1/64. So this is indeed the definition that mathematicians have done. They have defined that any number to the 0th power equals 1. And that then works with other laws of exponents really well. For negative exponents, this is the definition we use, that if n is positive, then negative n is here. It is the reciprocal of that base number to the nth power, okay? We make a fraction out of it. Nothing's actually negative necessarily. It becomes a reciprocal, a fraction. Now let's practice a little. We have here -2 to the 0th power. What's that? Okay, well, by definition, it's just 1. I forgot to mention that what about 0 to the 0th power? That's actually a little bit of an exception. Sometimes it's left undefined in some contexts, and sometimes it's defined as 1. Mathematicians are doing that type of stuff sometimes too. And then we have 5 to the power of -3. Okay, so we have a fraction. We're going to take a reciprocal, 1 over, and this whole thing to the positive exponent, like that. So we have 5 times 5 times 5 here in the denominator. So that's 125. 1 over 125. Then this one, can you tell me what it's going to be? 1 over something. You put 2 to the positive 5th power here. And so we get 1 over 32. Now here we're gonna simplify. In this expression there's some positive and some negative exponents. As you've already seen, that if you have powers that are multiplied and they have the same base, different exponents, you can add the exponents. That same law works here too. There's no problem at all. So we can actually take the 6 and the -3 and the -5 and add all those exponents, because the base is the same. There's 4, 4, 4. So -3 and -5, it's -8. And then 6. 6 plus -8 is -2. So first of all, this simplifies to 3 times 4 to the power of 2. And then 3 times, this becomes the fraction, the reciprocal, like that, but with the positive exponent. 3 times 1 over 4 squared, and 4 squared is 16, so we have 3 over 16. The next exercise is where we need to find the unknown. Okay, here it is. I found it. Just joking. Okay, find the value of the unknown is what I should say, right? What should x be to make this equation true? If you think about it, on this side we have 1, and on this side there's 13, 13, 13, different powers of 13. So we can combine these. Like I said, you can add these exponents when the base is the same. But 13 to what power equals 1? This must be 13 to the 0th power. That's what we are after. So what should x be so that these exponents, when you add them, you get 0? What do you get? I get -6. Is that right? Yeah, Matthew agrees. Well, good. Now we need to look at some of these negative numbers so we don't get confused. What if there's a negative number to a negative exponent? What if there's parentheses or there's no parentheses? Are these the same thing or are they all different? They're all different. This first one means -6 squared, okay? So it just means -6 times -6. So we get 36. It's not negative anymore. This one here does not mean the same. In this one here, it's only 6 squared, and then we take the opposite of that, okay? So the squaring, the exponent applies only to 6, not to the negative. So we first do 6 squared, that's 36, and then we put the minus sign in front of it. Okay, here we have negative exponent, and we have a negative number. The base is -6. So we use the definition. It is 1 over, and this same base, -6, and it is raised to a positive exponent. But no, not like that. I do need to have the parentheses here, because otherwise the exponent would only be applied to 6. It needs to be applied to the -6 here, okay? And so this one then turns out to be 1 over 36. Our last exercise for this lesson is to simplify this expression. Here we have -2 and -5 as bases. So we cannot combine anything. We cannot add those exponents. And yeah, 3, 2. So 3 different bases. We just have to calculate the value of each expression separately. 3 squared is 9. And everything is multiplied. And then -2 squared. -2 times -2. Here's a negative exponent here. So this is going to be a fraction. All right, 1 over, and this base number here, -5, to the positive exponent, 2. So what do we get? What do you get? 36 over 25. Good job. Okay, we're all done with this lesson.